everyone. مساء الخير وأهلا وسهلا فيكم ومرحبا بكم في المركز الثقافي الأمريكي في الجزائر. I'm Khaled, the embassy spokesperson. I know you're used to hearing me talk in Arabic more often, but today's talk is going to be in English because we have a very special guest who is Dr. Lindsay Hays. Dr. Hays is the Deputy Program Scientist for the Astrobiology program and the Mars Sample Return Campaign at NASA. And frankly, a lot of what you do is kind of beyond me, so I'll probably let you do the explaining and dumb it down a little bit for those of us who may not have a science background or maybe non-native speakers of English. But before I turn it over to you, I just wanted to thank everyone for joining us. The American Center in Algiers, or ACCA, is, of course, currently the actual ACCA is still closed due to coronavirus restrictions, but we have moved our programming online. So we are doing these talks once or twice a week, typically one talk a week in English, and then sometimes we have other talks in Arabic. And I also have a co-host today who is Andrew Lederman, or Drew, and he is a political economic officer at the embassy, and he is with us because part of his specialty is in environment, science, and technology. Drew, give people a wave so they know who you are. Okay.
Hey, everybody.
Okay, so now let's go ahead and turn over the floor to Dr. Lindsay Hays from NASA. Thank you so much for joining us.
Can you guys hear me? I'm glad to be here. Thank you so much for having me. I'm going to share a presentation with you guys. So can I get a thumbs up from you guys that you can see it? Is that good? Yep, awesome. Okay. So thank you both for having me. I'm really happy to be here. As Khalid said, my name is Dr. Lindsay Hays. I'm the Deputy Program Scientist for the Astrobiology program, as well as the Deputy Program Scientist for Mars Return. So I wear two different hats within the NASA program, and I help out with two separate programs that I hope I'll be able to sort of show you guys where the overlaps between those two are. So just to start off, I wanted to talk about a few individuals who sort of personally inspired me and who I think are doing some very interesting research right now, primarily sort of in space exploration or in astrobiology related things. So the first woman, of course, who definitely inspired me, her name is Sally Ride. You may have heard of her. Sally Ride was the first American woman in space. She wasn't the first woman in space. The first woman in space actually was a woman named Valentina Tereshkova. The Soviets beat us with the first woman in space, but she was the youngest American. She still remains the youngest American to have flown to space. And she actually was the first woman in space the year that I was born. So I think that that's a pretty cool tie, a pretty cool history to be following at NASA. The next woman who I think has, sort of personally inspired with the work that I do and who I think is doing some great stuff is actually this woman, Vicky Meadows. Professor Meadows is a professor at the astronomy department and the director of the astrobiology program at the University of Washington. And her work in what she calls the virtual planet laboratory has really sought to expand how we look at planets outside of our solar system and think about habitability and what planets around other stars may have life and how we can find them, what we might think about when we're looking for those planets. The third individual that I wanted to highlight as a sort of inspiration is Batul Kachar. She is an assistant professor of astrobiology at the University of Arizona. And her work is on the origins of life, early evolution and life in the universe. But she thinks less about sort of the whole planet, the way that Vicky does, and more about what molecules within cells and the earliest forms of life, what they looked like, how they did things. And I think she is really a good symbol of the future of astrobiology. She is a relatively early career person, but she's done some amazing things in her career. So I think Batul is just a fantastic role model. My personal background, I actually grew up in a place called Jupiter, Florida, just like the name of the planet. Jupiter, Florida is about an hour and a half north of Miami, Florida. But one of the neat things about Jupiter, Florida, it's about 3 hours south of where NASA launches most of its rockets. So growing up as a kid in Jupiter, Florida, I could actually see the trails of the space shuttle and other things that were launched from the the Cape Canaveral Space Center. And it was just really neat to be able to see these things, live from my backyard growing up. So I was extremely lucky. While I was at university, I did a summer job at one of the NASA centers, the Jet Propulsion Laboratory in Los Angeles, California. And the work that I was doing there was actually fairly boring. I was actually just looking at literally counting rocks on the surface of Mars. And the reason that we were looking for rocks on the surface of Mars was because as we were, so this picture here is a Viking, which landed on the surface of Mars in 1976. And one of the first things you can see is that there are a lot of rocks in this picture, which wasn't a huge problem for the Viking lander because it was relatively big. It was the size of a sort of a small car. And so it had the ability to land even on somewhat uneven ground and touch down without a problem. But when we launched the Pathfinder rover in 1997, this was a tiny rover. I mean, the Pathfinder rover was the size of a very small dog or a large cat. And we thought by looking at pictures that we had from our satellites in orbit that the place we were going to land Pathfinder was fairly smooth. And then as you can see in the picture here on the top, there were also a lot of rocks in that image. And because of the way Pathfinder landed and some of the subsequent missions landed, they had these fantastic like airbag style things where it came in and then they dropped this big airbag kind of thing and it bounced along the surface until it found a place. And so that wasn't such a problem. But our next mission, the Phoenix mission, needed to land in a place that was extremely smooth. It was going to scoop into the sand. And so we wanted to make sure it was extremely smooth. And so we wanted to figure out, how do we tell how many rocks there are on the surface? So I spent a summer looking at Mars, at pictures of the surface of Mars and trying to figure out where the rocks were and counting it and doing certain mathematical formulations on it and such. And here is a picture of the Phoenix lander. It landed in 2008, and you can see it does also look pretty smooth. And look at that. Look at how smooth that was. We were very excited to be able to see that we picked a nice, calm place for the Phoenix lander. And the really neat thing that the Phoenix lander did, you can see that scoop in the picture at the bottom left. The Phoenix lander actually identified the first evidence of water ice on the surface of Mars. So you can see that little white bit in the middle there. It actually evaporated after a couple of days, which is how we know it was actually water ice. So that was a really cool mission to be involved with. And after that, I was hooked. I was so fascinated with Mars and Mars exploration. So why Mars? What are we interested in exploring Mars? This is a picture taken from the Curiosity rover. Today's surface of Mars, it does not look like a habitable planet. And like I told you, I'm interested in astrobiology and the search for life. Mars doesn't look like a habitable planet today. It's too cold, it's too dry, it suffers without the sort of atmospheric surface like we have on this planet. It sees a lot of radiation from the sun and from other places outside of their solar system. There is no life that we know of on our planet that could live there. Even today at the equator, so at the hottest place on Mars, temperatures drop below 70 degrees Celsius every night. So it's a very, very cold place to be on the surface of Mars. And the warmest places on Mars barely get above the temperatures in Antarctica. So the very coldest places on the Earth. But as far as we understand, Mars wasn't always this way. Ancient Mars maybe had water flowing on the surface of it. Mars climate change effectively happened. Basically, the water on Mars, from what we can see in the geology, we see evidence of flowing rivers and things like that. Where did it go? What happened to it? So part of the reason that we want to explore Mars is to figure out how a planet that looked like it may have been able to have life early on in its history, no longer, how you lose that habitability, how you lose that ability to support life. It's something that we don't really understand in terms of planetary climates, how those changes occur. So this is what we call the fleet chart, right? This is all of the robotic missions that anybody has ever sent to Mars. You can see they go back fairly far, and it's worth noting how many of these lines end in little red X's. Those are missions that failed for one reason or another. Some we understand why, some we're still not entirely sure why we lost them. But you can see there were a number of Soviet Union missions, the United States has sent a number of missions, Japan has gotten involved in sending missions, and most recently, India and the United Arab Emirates have both sent missions to Mars. And this is particularly interesting. Mars is a great and really interesting place to be. And so, I like to think that this is a truly international effort as we go and try and explore. In some ways, even though I mentioned it was very cold and very dry on the surface of Mars, in some ways, Mars is sort of our nearest neighbor in terms of the similarity of the surface. So you guys may be familiar with the Perseverance rover. This is the most recent rover that we've landed on the surface of Mars. All of these arrows point to various instruments. We have different cameras, we have a weather station, we have something that's looking into the subsurface using radar, and we have a number of instruments that are out there on the arm that are used for measuring the surface and looking at different things, specifically at rocks. The Perseverance rover recently landed in Jezero crater. So this is a sort of map view of all of Mars, and you can see the arrow point to where Jezero crater is. In terms of context, on the left, you can see the globe and the Jezero crater. Jezero crater is at the edge of this really, really big impact basin. It's a smaller impact basin on the surface, or right at the edge of this bigger impact basin. But there's some evidence that the edge of this may have been sort of at the edge of what was a global sea at the northern edge of, at the northern part of the planet. So we're really fascinated about what that environment may look like. And actually, this here is a sort of three-dimensional image of Jezero crater. This is a U.S. Geological Survey map of Jezero crater. And what you can see here is this is basically a river delta. You can see at the very top coming in from the left, the sort of flowing river delta. You can see the sort of braided stream that comes out of it. The valley at the top is called Narrativa Vallis. The crater that you can see sort of right in the middle of the image is called Belva crater. And what we have here is evidence of a period in Mars's past where water was flowing from higher elevation down to lower elevation. Deltas occur when you have rivers that meet sort of standing water and deposit a lot of things. And that little red image at the bottom, sort of to the left a bit, is actually where we landed the Perseverance rover. So the exciting thing that we're going to be doing is driving up to that, the delta there and exploring it. And the neat thing for me as an astrobiology person is that from what we know, river deltas are habitable environments. They're places today where life exists, where life lives, and nearly as importantly, they're places where they collect sediment from upstream, they deposit those pebbles and rocks and stuff in the delta, and then quickly are sedimented on top of by further rocks and soil and those sorts of things. So not only are they places where life lives, but they're places that preserve evidence of those life, those biosignatures, those fossils and such for long periods of time. So that's part of the reason that we're particularly excited about going to Jezero crater. So the Perseverance rover, this mission has four primary science objectives. Three are really trying to understand the possibilities for life on Mars. So three are looking for ancient microbial life. Look at the geology, look at the rocks, tell us what the environment was like. The second objective is really astrobiology. Look for those signs of life, look for those fossils, basically. The third objective is to collect samples for later return. And then the fourth objective is really thinking about the possibilities of human life on Mars. It's to prepare for humans, to prepare for human exploration, to think about what are the risks to having humans travel to Mars in the future, and what are some of the resources that might be there for future explorers on the surface. Now, the other really cool thing about the Perseverance rover is that it carried the Mars helicopter Ingenuity. Now, this is small, right? This is only about 1.8 kilograms. It's a relatively small little thing. Think about a little camera, basically. The wingspan is huge because the Martian atmosphere is not particularly, you have to have really big wings because it's a very thin atmosphere. It was named by the student Vanessa Rupani, and it is currently sitting on Mars' surface with the first flight planned for this weekend, early on April 12th. So I guess that's technically Monday, a week from, or, next Monday. This is sort of hot off the presses. This is one of our most recent pictures. This is the first selfie that the Mars 2020 rover has taken. And you can see in the corner there, a tiny little picture of Ingenuity that's sitting on the surface. We've set it down and we're ready to move on and see whether or not we can fly a powered flight on another planet. So that's particularly exciting. So the thing that for me is most exciting about, as the Mars sample return deputy program scientist, the thing that's particularly exciting for me is the fact that the Mars 2020 rover, the Perseverance rover, is planned to collect samples, to drill samples of rock, to put them in these little tubes and to leave them on the surface. Then the idea is it'll, go to different places, pick up particular interesting rocks from here or there or whatever, deposit them in a single place for return by future missions. So to talk a little bit about that, we're actually looking at a three separate pieces to a Mars sample return campaign. So the Mars 2020 rover Perseverance will collect the samples and put them on the surface. The next mission is actually a joint NASA European Space Agency mission that will land a lander on the surface of Mars. A rover will go collect those samples that were deposited on the surface, bring them back to the Mars Ascent Vehicle, which is a small rocket that will launch off the surface of another planet for the first time, carrying a little ball where the samples are contained. That goes into orbit around Mars and then gets collected by this mission, this satellite. It's an Earth return orbiter, captures it and brings all of those samples back to Earth. So it's a 3-mission campaign to return samples from the surface of Mars. And we are here. The maximum number of samples that can be brought back is about 35, and that will be about half a kilogram of rock sample, which doesn't sound like a ton, but if you think about the fact that this is the first time that we brought back rocks from another planet, that's a really big deal. There's a lot of science that can be done back here on Earth once we have those rocks in hand, as it were. So for the last little bit, I'm going to talk a little bit about astrobiology. I've been sort of hinting at it. Astrobiology, the search for life, has been part of NASA since the beginning, or nearly since the beginning, right? Astrobiology has been part of NASA's mission since 1963. NASA's only been around since 1959. So we were nearly there at the start. In astrobiology, we define it as the study of life in the context of the whole universe. And we focus on 3 fundamental questions. The first is, how does life begin and how does life evolve? So on this planet, what were the conditions that allowed life to originate, and how have those conditions and the planet changed as the planet has changed together? We think about, what is the future for life on Earth? What does habitability look like over time? Like I was mentioning, we think Mars early on in its history could have supported life, but doesn't support life now. And how do those changes happen to environments that allow life to either continue to live on this planet or keep life, sort of give it a limit? And then finally, does life exist elsewhere in the universe? And so this is kind of related to the things that I mentioned Professor Vicky Meadows does, thinking about habitability on planets outside of our solar system, thinking about habitability on Mars, thinking about habitability on some of the icy moons in our outer solar system. Where might life exist elsewhere? How might life exist elsewhere? What might that look like? And so in thinking about that, we sort of combine 2 different things. So in thinking about how did we get here, where are we going, are we alone, we want to combine our knowledge of Earth organisms, the things that we see on our planet, the places that we could go, the things that live at the extremes of temperature and pressure and dryness and things like that. How do we combine that knowledge with the knowledge of environments in outer space, right? Things like what the conditions are on Mars or what the conditions are on other places. And we need to combine both of those ideas, the astro and the biology, to get at astrobiology. And really fundamentally, the search for life is a search for habitat, right? Where might life live, what conditions, and what happened here on our planet may have happened many, many other places in the solar system and beyond. And so, we're searching for those things as we're thinking about life. And I'll finish up with this quote: the very nature of space is discoveries, and the best of these are discoveries. The best of those discoveries are the ones you don't expect. And so I will leave this up for a bit. This is some additional resources, some of the websites where you could go and look at pictures and such of the Mars 2020 mission, find out more about the Mars 2020 mission. That last link there, the mars.nasa.gov/technology/helicopter, and then #watchonline, that's actually the one where I believe the video starts at 3:30 a.m. Eastern time, which may actually be a reasonable time for you guys. But on April 12th, that's where I think the live video of the feed coming back for the helicopter will be. And then I also wanted to point you to, if you're interested in astrobiology, we have these great graphic histories, which are sort of like comic books or graphic novels that tell a little bit about the history of astrobiology, some of our astrobiology related missions, some of the topics in astrobiology, and they're illustrated, but you can read them online, and they're pretty cool. I think they're really neat. I've used some of the images here in my presentation. So I think I will stop sharing at this point, and I think the questions is next.
Yeah, thank you so much for that, Dr. Hays. We do have a lot of questions. I'll start with two from William Lopewi, I think. William asks, first, can you talk a little more about how the Mars rover, how it landed on the surface, like the mechanical process? And secondly, he wants to know if there are any internships for foreign students at NASA.
Okay. Hi, thank you for your questions. Those are really great questions. The first one, to answer the first one, unlike, so I'll actually go back just a little bit. The Curiosity rover, not the Perseverance rover that we just landed, but the last one that we landed a couple years ago, got big. It was way bigger than we can land with the method I was talking about earlier, where you drop basically a large airbag and it just sort of bounced it along the surface to a place and then opened up. And so for both the Curiosity rover and for Perseverance, we had it was somewhat audacious as it is. It came in on a parachute. It had a heat shield because Mars does have an atmosphere. And so that sort of slowed it down a little bit. It opened a parachute to really, really slow it down. And then when it started hanging from the parachute and got to a certain elevation, Perseverance actually had something called terrain relative navigation. So it was able to take a couple of pictures of the surface, compare those to some pictures that it had sort of stored in its computer memory, and say, okay, we want to land right there, basically. It dropped the parachute. It had basically a jetpack backpack that held the rover. It got to where it needed to be, where it decided it wanted to be. It lowered the rover down on a tether. When the rover wheels indicated that they had touched the surface, all of the connections to that rocket backpack broke. The rocket backpack flew off and intentionally crash landed somewhere else. And the rover was sitting on the surface. So that's how both Curiosity and the Perseverance rover landed. There's actually some really cool video of that whole process. The pictures that were taken, sort of extremely rapid pictures. So you can actually, there are still frames, but you can see they've been stitched together into a video. So I really encourage you to go look at those images because they are just amazing to see that process of landing on the surface. In terms of internships, NASA internships are available to students within the U.S. So if you are a student in the U.S., and affiliated with a U.S. university, there are internships that are available for those students.
Great. Thank you very much, Dr. Hayes. And I'm always fascinated and impressed with the amount of planning that goes into some of these missions. To think that you need one mission to collect the samples, another mission to bundle them up, and then another mission to bring them home is really interesting. I noticed in your presentation when you had 3 main goals for Perseverance, and then you had a 4th goal. And we had a few questions about that 4th goal from Qasim and Lauren. So human exploration of Mars. When do you think that's a possibility? I know there was a lot of discussion about that in the last administration. Is that still a focus of NASA? And can you talk a little bit more about that? Thank you.
Sure, definitely. What I'll say about the 3 mission process for bringing samples back is, in space exploration, we like to joke that you want to keep the number of miracles required to every mission down to 1. And the thought was, with Mars sample return, there are a lot of new things that we need to do. We need to launch something off the surface of Mars. We need to collect samples on the surface. We need to capture something in orbit around another planet and bring it back. And so it was thought that it would be better to allow, the scientists and engineers who work on these things to sort of focus on one problem at a time and address those individually. And so, it was split into 3 missions. I'm excited to see how all of them are coming together. It's absolutely fascinating to see. And again, it's truly an international effort since we're working with the European Space Agency partners on that. But to answer the questions about human exploration, I have another sort of offhanded comment, which is, there was a joke in spaceflight, in exploration that Mars sample return was always 20 years off. Right. And then we landed Mars 2020 and it's like, okay, we're collecting the samples. The plan is to bring those samples back in the sort of early 2030s. So that's pretty exciting. And now that, Mars sample return looks like it's a thing. I mean, Mars exploration and sending people to Mars. I was just listening to somebody talking about this recently that, it's been a goal of NASA, sort of since the start. It's been a sort of very far off long-term goal since the start. In fact, Wernher von Braun, who helped create the first NASA rockets, was actually ultimately interested in sending people to Mars. So, I mean, this has been something that's been sort of part of NASA's, we really want to do that for a really long time now. And I would say that right now we have the Artemis program, which is the goal to get back to the moon. And there are a lot of reasons why the moon is a really great sort of stepping stone on the way to Mars, right? It's a way to get back to spending time on another body in the solar system. The good thing about the moon is it's relatively close. So if there are any problems, you can easily come back. But there are, as I mentioned, sort of when I was talking about that goal, there are things about Mars that we know are different than the moon, but we don't necessarily know how different they are and what exactly, in what ways they are different. The example that I always like to think about is until we sent people to the moon, until the NASA astronauts, the Apollo astronauts went to the moon, we didn't know that the regolith, the dust basically on the moon was incredibly sharp. And it became a really big problem for our astronauts who were on the moon because it would get into, the pieces of their spacesuit. And after spending time on the surface, they would have trouble actually moving the joints in their spacesuit because they were filled with this tiny little, very, very, very sharp, like little shards of glass, basically. And that was something that we didn't know until we went to the surface of the moon. And so as we've thought about exploring the surface of Mars with people, with astronauts, we've thought about what we call strategic knowledge gaps, right? Things that we don't know, but we know we don't know them. And so the goal of a lot of our missions, including sample return, is to start addressing some of those strategic knowledge gaps. What exactly is the dust on Mars like? What can we learn from it? What are the things that we may be concerned about if we got, that we may need to think about how do we address these things if we're going to send people to Mars. So, it has always been, and it continues to be a NASA goal. But at this point, and under the current administration, our goal right now is to think about getting people to the moon. But, I will say President Biden famously has a piece of the moon in his office at the White House, and we are particularly excited about the fact that he seems particularly excited about Mars sample return. And so, you know, that may lead in really exciting ways about humans' exploration on Mars as well.
Great, thank you for that, Dr. Hays. So next, so we actually have a lot of questions, but I'll take one from Afaf Aniba, who wants to know how has our knowledge of the solar system helped us improve our living conditions here on Earth? Can you talk a little bit about how the technology we have acquired from space exploration has helped us on Earth?
Sure. You know, there are a lot of things about, you know, so I'll start off by saying, you know, my place in NASA is actually the Science Mission Directorate, which means all of our robotic missions, all of our exploration with robots and those types of things. And the Human Exploration Directorate is sort of a separate piece of NASA. And so, you know, I don't have quite as many, you know, lists of things like that in terms of those things. But some of the most common things are, you know, technologies we've developed for keeping our astronauts safe and healthy. Have been particularly good in terms of things we use to make us, you know, to look at, you know, medical conditions and address medical conditions here on Earth. Other things that we've developed are certain technologies that have, you know, sort of wide applications, communications technologies between satellites, you know, and those sorts of things have really improved our ability to communicate, you know, around the world and more rapidly and things like that. And then I think that, you know, from a science, so that's more from the technology and the medicine side of things. But, you know, I think from a science perspective, I think exploring throughout the solar system has helped us realize that that habitability of a planet and changing conditions on the surface of a planet are real things that happen, and understanding how certain feedbacks can happen at a local level, how, you know, burning fossil fuels and things like that can affect both the local environment and the planet as a whole. I mean, as I mentioned, there is global climate change that we have seen on Mars. We know it happens. We know the surface of Mars went from a certain set of conditions to a very different set of conditions. And it helps us to sort of see how those changes, you know, to sort of have a different perspective. I mean, the surface of Venus, I didn't really talk much about Venus, but Venus is basically a planet that is nearly the same size as the Earth, but instead of all of the carbon being, or most of the carbon being trapped within the rocks in the planet and such, most of the carbon on Venus is in the atmosphere. And Venus is, you know, a terrible place to be. The surface is extremely hot. The atmosphere is extremely thick. There's sulfuric acid. It's a really, really bad place to be. And it really shows us sort of different conditions and how, you know, things that we need to think about for the planet as a whole. So I hope that answers your questions. I'm sorry I don't have the, you know, 7 greatest inventions from NASA and their application to the broader world.
Thanks, Dr. Hays. I've always been told that they're Velcro and duct tape, I think, right? Those are NASA creations.
Those are definitely some important things. And, you know, I mean, I have 2 young kids, if you can tell from the artwork that I have behind me. And I know that at the very least, Velcro is incredibly important to get them dressed in the morning. Those shoes would just not be the same without Velcro. So
same thing with my son, so I understand. You mentioned Venus, and the James 23 had a good question about what other missions are either ongoing or sort of in the works for exploration of other planets. And it's interesting that you learn different things from different planets depending on their composition and what kind of a planet they are. So are there other missions to other planets that are in the works?
Yes, definitely. 2 that I am particularly interested in right now that aren't ones that are being flown. I mean, right now there are missions that are coming back or will be leaving an asteroid. The OSIRIS-REx just recently sampled an asteroid for the very first time. It ran into the surface, it collected a whole bunch of rock off the surface. It will be leaving the orbit around that asteroid pretty soon and returning those samples to Earth, which is absolutely cool. There's the Juno mission, which is around Jupiter right now, which is taking some really cool pictures and helping us really peer beneath the clouds on Jupiter. But those are two that are currently happening. Future missions, two of the ones I'm most excited about, there's the Dragonfly, which is a mission that will go to the Saturn moon Titan and will land on the surface. It is an octocopter, which means that it has four basically sets of two helicopter wings, and it will land on the surface of Titan, sample the surface, take off, fly somewhere else, sample the surface there, take off, fly somewhere else, and it will actually take these fantastic pictures of the surface of Titan. Titan, of course, is extremely cold and has an extremely thick atmosphere. And the really neat thing about the surface of Titan is it's so cold that that water there is the rocks, but there's liquid methane and ethane flowing on the surface of the planet, forming lakes and rivers and other things like that. And so it's a really, really interesting moon that we will be exploring soon. The other mission that I'm particularly excited about is the Europa Clipper mission, which will fly to the Jupiter's moon Europa and will fly around multiple times. Now, Europa is a planet that has an icy surface, and a moon that has an icy surface, and as far as we can tell, it looks like it has a subsurface ocean. So it looks like it's an ice shell around a subsurface ocean around a core of this moon. And it's absolutely interesting because it looks like it might be a very likely place for there to be life in our solar system, right? We see on our planet hydrothermal vents in the deep ocean. We see these towers, these chimneys, where very, very hot, where deep ocean water gets circled up through, it connects with the subsurface, it creates all these environments that microbes just love to gobble all of the chemicals that are coming out there. And so this mission it won't land on the surface of Europa, it'll fly around Europa, taking a bunch of pictures and taking a bunch of measurements and helping us better understand what Europa might look like under the surface. And then, one other mission that I think is really cool, it's not a NASA mission, it's actually a JAXA, the Japanese Space Agency. It's called MMX, and it's the Martian Moons Explorer. Mars has two moons that are absolutely tiny by sort of the standards of our solar system. They look like they're sort of captured objects, things that were flying relatively close to Mars and got captured into orbit around Mars. And some recent evidence indicates that they may even be like one object that then broke apart and is now two separate moons. And the Martian Moons Explorer MMX mission is, like I said, coming from the Japanese Space Agency and should land on the surface, take some samples. It will be a really interesting thing to learn about these moons. And I could go on and on and on and just list all of the cool missions that we're doing, but I imagine we may have some other questions. So
I can tell you really love your job. You get very excited and passionate talking about it.
I am extremely lucky to be able to do something that I really, really enjoy. So
great. So our next question is from Nina Meline, who wants to know a little more about spaceships and what I know that's not exactly what you work on in NASA, but what does the sample storage area look like inside a spaceship, and how does that impact our ability to plan for potentially sending people to another planet or to the moon, etc.?
Yeah. So every pound that we launch on a spaceship requires a whole bunch of rocket fuel and a whole bunch of other things like that. So it's like any trip you take where you want to use every little pocket effectively and efficiently. And so when we think about so returning samples from Mars, one of the things that we want to be very careful about is something that at NASA we call planetary protection. And the idea of planetary protection is we want to be very certain that any samples we bring back from Mars doesn't have anything that would have any negative effects of the life on this planet. And so currently the plan for sample returns from Mars, doesn't actually involve landing them on a spaceship or collecting them with a spaceship that humans might be in or might be working on. But when we talk about going to the moon, for example, with the Apollo program, the sample containers, they had, sort of like little, almost suitcase-sized boxes that they put different rocks in that they found interesting. Famously, one of the Apollo astronauts sort of said, well, we put all these rocks in, but there's a lot of extra space, and just sort of shoveled a whole bunch of sand basically into the bucket. And there's been some really interesting science that has been done on just these grains of sand that were just sort of added later to the box. And so, so sample containers, they depend a lot on what planet you're going to, whether or not we are concerned about whether or not there might be something that could be harmful potentially to human life or to life on this planet. And that's a thing that we take extremely seriously at NASA. We have a lot of protocols in place for managing those things and everything. But when you go to somewhere like the moon, you want to take back as much as you can, knowing, of course, that every pound counts, every kilogram counts. And so, the sample containment and sample collection and sample return things right now vary greatly depending on where you're bringing samples back from and what they look like. Generally, we try and seal them up as tightly as possible and be as careful with them as possible, just to make sure that we don't that we don't lose any, because this is precious stuff. But, like I said, the samples that we're returning from Mars are sort of about like a size of a pencil or a pen. Whereas the samples that we return from the OSIRIS-REx mission from the asteroid are, it was sort of in a big container, because we were just hoping to collect as much as we can. So it varies greatly depending on the mission.
Thanks for that answer, Dr. Hays. I noticed in your presentation that you, at the beginning, highlighted 3 women that have influenced your career and influenced your interest in the sciences. And science education here in Algeria is quite important. And the majority of students who go to university study science or medicine or other subjects like that. So what advice do you have, as last month was Women's History Month, what advice do you have for women who want to study the sciences, not only here in Algeria, but in general?
Thank you for asking that question. I think that's a really important question, because, I know that there are a lot of different perspectives on the kind of science that is out there, the kind of science that perhaps women may be more interested in, the kind of science that is out there. I think that there is a lot of there are a lot of important questions, and I really like that quote. And the reason I finished with that quote by Neil deGrasse Tyson is that there's a lot of things out there that we don't know. And to me, science is really just the process of seeing something that you don't know the answer to and being intrigued by it, and a sort of, how do I approach it in a systematic way? How do I go about finding out more about this, finding out what other people know about this, finding out sort of the limits of, our collective knowledge to that. And I think that, as long as you are interested in asking questions, and as long as you are interested in finding out more, I mean, that's the basis of science. That is science, right? Whether or not you're doing it in a lab or at school, or, you're a doctor and you're trying to, figure out what's wrong with this patient, or, you are an astronaut and you're trying to do an experiment on the International Space Station, or, whatever it is. And so, I think my absolute baseline advice is be curious, wonder, and ask questions, and and be interested in finding out more. Keep an open mind about why this might be or that might be, and keep searching for more information and finding out more, because there's a lot of just really cool stuff on this planet and beyond this planet that's worth finding out more about. So that's my advice.
Thank you for that. And there's a question that's been asked a couple times, so I feel like I shouldn't skip over it. There's people who are interested in SpaceX and want to know more about what is the connection between SpaceX and NASA, and how does that work in the American system, since you have a government agency and a private company?
Yeah. So SpaceX is a private company, as you said. It is, Elon Musk is, of course, the figurehead, but the primary person running it is actually a woman named Gwen Shotwell, who is, fantastic and, also really inspirational. But the interesting thing about, so SpaceX, like Lockheed Martin and like a number of other agencies that NASA, or a number of other countries that NASA has partnered with in the past, the primary connection there is that effectively we buy rockets. We buy rockets to launch things into space from SpaceX. And, we have launched satellites on SpaceX rockets. We have launched a number of different missions. We've launched some resupply missions to the International Space Station. And most recently, we've launched some astronauts to the International Space Station on SpaceX rockets. SpaceX is, a different kind of company than Lockheed Martin or some of the other companies that we've partnered with in the past, or Boeing that we've partnered with in the past to launch things, because they have a much more sort of quick design and turnaround, which, sometimes causes a little bit of friction with NASA, because our favorite word at NASA is heritage, right? We want to know that if we're going to launch something, it's going to be successful. And, NASA and SpaceX is really, sort of pushing the envelope, changing things a lot, improving in a lot of ways. And so I think that what you're looking at there is what will hopefully be a long and fruitful partnership between NASA and SpaceX as a way to help us both achieve the goals that we're getting at, which is more exploration of space, more going to different places, more getting people into the orbit, and all that kind of stuff.
Dr. Lindsay Hays, thank you so much for being with us today. Our audience has been very enthusiastic, and they've been asking more questions about Mars and space travel and gravity and everything you can imagine than we could possibly answer. There are many unanswered questions in the chat, so I apologize to those people whose questions we did not get to yet. But thank you again for being with us today. And to the audience, I just wanted to say that, of course, Ramadan is coming up. And so we will be having a special program here on our YouTube channel in Ramadan. We'll be starting next Wednesday, April 14th, with a live chat with a panel of American Muslims about what it's like to commemorate Ramadan in the United States. And the week after that, we will have a talk with a Syrian American poet who will talk about her experience being a Muslim woman wearing the hijab in the United States. So please be sure to press the subscribe button below. And thank you everyone for joining us. And Dr. Hays, thank you again so much for being with us.
Thank you. It's been a pleasure. They were great questions. So I'm very happy to be here.
Okay. Thank you, everyone. We'll go ahead and end the stream.